Okay. Hey everyone. Good morning. So starting our live lesson for the day. If for some reason you aren't able to catch it, I'm going to upload the link to it on the remote learning schedule I put out for you all, where it lists each of the things that you'll be doing each day and the due dates. So please make sure you access it so you can have the things you're supposed to be doing for the week. All right. So just relax. If you have any issue where you can't access something, send me a remind message, but go back and check all the remind messages and make sure that you're using the correct link. I sent out two links. One of them is if you don't have access to your Henry Counter device. Then the other one is if you do have access. So please use both of the links to make sure everything works, okay? So this video is for Algebra 1. I'm going to make the video tomorrow for geometry because obviously 7th period tomorrow. So today is Algebra 1. If you need the code for remind, it's on the information that's sent as far as remote learning. All the stuff is there, okay? So please, please, please make sure you go back and look. Remember, at the end of each period, the last 30 minutes, that I will have time. Good morning, everyone. Good morning. I will have time to help you one-on-one. We just found out that we won't be able to see you on video on Google Meet, but if you need to show me something on your screen, there is another program that we can use. All you have to do is just send me a message saying, hey, Ms. Dean, I can't access certain things, or I need you to see what I'm seeing on my screen. And if that happens, just send me and I'll send you the link so we can share your screen and we can talk one-on-one, okay? So before we get started with this first lesson, are there any questions about any of the documents or anything thus far? Okay, so this video is for all Algebra 1. It's just, I'm making them in the mornings. So if you're like second period or first period, this would be the time that you would be asking me questions from like, what is it? 9:15 to 9:45, but anybody can come in during a live session. It's not limited to class period, so anybody can come in. I hope that answers your question. Are there any other questions? Okay, well, if there are no further questions, so if you go to the actual schedule, I have different tabs there. And one of the tabs for the tab for Algebra 1 is there, and then there's a tab for my honors geometry class. But okay, so basically the notes that I'm going to use today are in the actual document. It's an Excel, well, it's Google Sheets document. And then it tells you the name of the USA test prep assignment that you'll have in regards to this. And it tells you when it's due and a self-check quiz. So when you get done, if you have things you want to check yourself, you can have that available to you. Okay. All right. So let's go ahead and get started. Okay, so today we're dealing with exponential word problems. Last time in class, we was doing exponential graphs. So we did domain, range, intercepts, asymptote, and then move left, right, up, down. Today, starting with exponential graphs. No, I'm sorry, exponential equations. All right, so this is real simple, real easy. I have my iPad here. I'm going to kind of hold it back and forth so you can kind of see it. But this is the page. This is the sheet that you can get, and it's with the notes on it. Okay, so let's see. I know the glare. Might have to turn down the brightness on this. So give me a second, because depending on the actual program determines. Determines what happens. No, it's not on Google Classroom. If you go back to the if you go, excuse me, let me get the link real quick. If you go here, I just put the link in the comment section. That's the link that you would need to use, and it has the drop down for you all as far as what you would need as far as assignments. Okay. All right, let's see if this will work better as far as brightness. And this camera, this is learning for all of us. I might just have to do it on a sheet of paper because it's acting strange. All right, let's just do it on a sheet of paper. Give me a second. All right, sorry about that, everyone. So I just sent the link to the document that I'm referring to in these notes. So basically we have equations. So we have growth equations and decay equations. Remember, growth is when it's going up, decay is when it's going down. So we have growth and decay equations. All right, so we have growth and decay. So we're going to have two equations for the first one for growth. It's real simple. It's going to be y equals p 1 plus r exponent t, okay? So that's going to be our first equation, y equals p 1 plus r to t. So real simple. P is how much you start out with, okay? 1 is always going to be a part of the problem, and then this r is the percent or the rate that they tell you is going up by or down by, and then t, of course, is time. So p is the starting amount, 1 is always a part of the problem, r is the rate, and then t is the time, okay? So we have some things. We also do it with decay. So we have y equals p 1 minus r exponent t. So if you look, there's a slight difference in both equations, the subtraction sign for decay and the plus sign for growth, all right? So when we start doing some of these, the word problems is very straightforward on what they want you to do. It's just, you have to be careful in reading the problem, all right? So number 1, okay? So let's see if I can get this to work. Still a no-go. All right, anyway, so here we go. It says you deposited $500 in an account that pays 5% interest. Everything that is on there that says your assignments is for a grade. So all the things that has a due date is for a grade, okay? All right, so back to the problem. It says you deposit $500 in your account that pays 5% interest compound yearly. Find the balance after 6 years. Okay? So you start out with $1,500 in your account, $1,500 in your account. So remember, P is how much you start out with, okay? And it says you get 5% interest. So when you think about interest with accounts, that's money that you're earning. So you have to decide, is that going to be growth or decay? Well, you're earning interest, so that's going to be growth because you're earning. So we're going to use the equation that looks like this, all right? So we start out with $1,500. All right. So we start out with $1,500. The 1 that's here is always a part of the equation. So it's going to be 1 plus the rate. Okay. It said that you are earning 5% interest. All right. So the rate is going to be 5%. Remember, we don't write percents in problems. We put them as decimals. So 5%, remember, it's going to be 0.05. All right. So we got 0.05 in there. All right, and the last thing we got to do is time. Well, it said over 6 years. So for time, we're going to put in 6. So this is what you would put in your calculator, 1,500, parentheses 1 plus 0.05, exponent is 6. All right, so you just put it in your calculator and you will find out how much money you will have after 6 years. So you can use either Desmos standard calculator. If you have a handheld calculator or the calculator on your cell phone, you can use that. Either one is fine. So 1 plus 0.06, 0.05 raised to the 6th power. Okay. So when you put it in the calculator and you get your answer, you'll find out that in 6 years, you will have made $2,010.14. Okay. So this literally just put that same exact thing in the calculator. That's all you have to do there, put that in the calculator, all right? Anybody have any questions about this first problem? We're only doing 5. Anybody have any questions? Okay, so we're good there? All right, so we're good. We'll keep going to the second one, okay? So on the second one, it says, okay, the mouse population is 25,000 and is decreasing by 20% each year. Write a model, which is an equation for this situation. What will the mouse population be after 3 years? All right, so the mouse population is at 25,000. It's decreasing, okay? It's decreasing. So because it told you it's going down, that's not going to be growth, that's going to be decay, all right? So it's decreasing by 20% each year. Write our equation and find out what's the population after 3 years. So this time we're going to use decay because it said it's decreasing. So we're going to just have a subtraction sign in our problem this time. So the initial amount for the mice is 25,000. 1 is a part of the equation minus the rate. The rate was 20%. Time was 3 years. So I'm going to write that out for you. So we get 25,000. 1 minus the rate, which was 0.20, and time was 3. All right. So we're decay. So 25,000 is the starting amount P. The rate is 20%. Remember, we write it as a decimal, so 0.20, and it said time was after 3 years. So this is your model right here. All right. And we just throw this in the calculator, and we'll get our answer for how many mice will be left after 3 years. So 25,000, parentheses 1 minus 0.20, exponent 3. And when you put that in the calculator, you should find out that there will be 12,800 mice left after 3 years. Okay. That'll be that many mice left after 3 years. All right. Any questions about that one? Okay. Pretty simple. It's just really just plugging into the equation and putting it in the calculator and getting your answer. All right. That's all you're really doing the entire time. Making sure though that you use the right equation, addition or subtraction, because if you use the wrong one, of course, it's going to give you the incorrect answer. All right. All right. We only got 3 more. All right. So here we go. The number of mosquitoes at the beach tripled every year since 1999. In 1999, there were 2,500 mosquitoes. Write a model for the situation. And how many mosquitoes would you predict were at the beach in 2005, all right? So you know it started in 1999 and that it tripled every year and that there were 2,500 mosquitoes to start out with. So do you think this is going to be growth or decay? Since it said it's tripling. Okay, good, good. It is going to be growth. It is going to be growth, all right? That's true. Okay, good. So pretty simple, right? Growth, triple, duh. So let's look though. So we know it's going to be our growth equation, right? But because of the wording of this problem was a little different, it said it grew, like it said it tripled, So we're not going to put 1 plus r this time because it said it's tripled. We're only going to mainly use this 1 plus r situation when they tell us a percent, all right? If they tell us how much it went up by, like if it doubled or tripled or halved or did whatever, you don't put the 1 plus in there, all right? So it's really just like y equals p r t. So if you ever have a problem where it said it tripled, it doubled, it halved, it did that, don't put the 1 in the problem anymore. Just have the rate, all right? Just have the rate, all right? And it said it tripled. So if it said it tripled, how much is it going up by each time? If it tripled. Anybody? Okay. Yeah. By 3. So when we write it, we know it started out with 2,500 mosquitoes. So we know we're going to have 2,500 mosquitoes. It said it tripled, and y'all put in 3, which is tripled, which is true, all right? Now, the last thing we got to do is we got to figure out the time, okay? So it was 2,500 mosquitoes. It said it tripled, so y'all are right, it's going to be 3. Now we got to figure out T, all right? It said it started out in 1999. So 1999 was the base year. And we want to know how many mosquitoes we ended up with in 2005, right? So the question is, how much time is it from 1999 to 2005? And think of 1999 as year 0. So like 1999 is year 0. Okay, y'all be careful. It's not 6. It's not 6. Think about 1999 as year 0. So 1999 to 2000 is 1 year. Yes, that's right. Dreamy, I don't know who this is, but yeah, you're right. So 1999 to 2000 is 1 year. 2000 and 2001 is 2 years. 2001, 2002 is 3 years. 2003 to 2004 is 4 years. 2004 to 2005 is 5 years. So it's actually 5 years of time, okay? So be careful. Remember, time is different from just regular numbers. All right, Joseph, thanks. Okay, cool. So it's 5 years. So the amount of time is 5 years. So if they ever give you a problem when they say from this year to the other year, like a lot of you did 1999 plus 6 and got 2005, subtract 1. And that will always give you the correct answer, okay? So it's going to be time is going to be 5 years. All right, so time is going to be 5 years. All right, so just put this in the calculator. So 2,500 parentheses 3 exponent 5. You just throw that in the calculator. Exponent is 5. So we found out it's going to be a whole lot of mosquitoes. There are going to be 607,500 mosquitoes. That would be the new mosquito population in 5 years. So that's a lot of bugs at this beach. All right. Any questions on that example? Any clarifications needed? Yeah, that is a lot of mosquitoes. Yes, it is. But that's real life though, because mosquitoes really are like that. They can populate very quickly, except it's a damp area. That's why they say they don't have a lot of standing water, because they really can populate extremely, extremely quickly. All right. It seems like based on responses, we understand. Okay. We got a bug in the comments. All right. Let's get these last two problems done. I'll answer that a little later regarding my weekend. All right. So let me get these last two, then I'll go there. Okay. So number 4, given the model. So this time they gave you the equation. All right. They gave you the equation. Tell whether it represents growth or decay. And then tell the decay factor, the percent of decay. So basically they gave us our problem. So it's y equals 200 parentheses 0.80. What is that in x? Okay, in x. Right. Problem. Okay, hold on, y'all. Okay, so it's really what's in the problem, all right? So let's look here. We know this is a starting amount. We know this in here is the rate-ish time period. So the question is this going to be growing or decaying? What do y'all think? Think about what we talked about with growth or decay in class. As far as it grows, if it's greater than 1, or it's decay if it's between 0 and 1. So on this one, do you think this is going to be growth or decay? Remember, that's 0.80. Okay, so for those who said decay, you're right. Remember, growth is if the number is 1. So 0 and 1. All right, so and remember, decay is any number between 0 and 1. So this one is going to be decay because 0.80 is definitely not greater than 1. And then decay, 0.80 will be a number between 0 and 1. All right, so they'll just ask you that sometimes. What is it? Did it grow or did it decay? All right. So we know it's decay because 0.80 is less than 1. All right, the last thing we have to figure out is what is the decay factor? All right, so it's saying like how much did it go down by each time to get to this number to be 0.8? Well, let's go to our problem, right? So our equation for decay is 1 minus r. So 1 minus something gave us 0.80. So 1 minus something gives us 0.80. The question is, what is it? What gives us 0.80? So 1 minus the rate gave us 0.80. We need to figure out, because that's what we're going to call the decay factor, because they didn't actually tell you the rate. It's just when they subtract the two numbers, they found out the rate was 0.80. All right. So anybody got an idea? 1 minus what number gives us 0.80? If not, it's okay. Okay, so I'll do it so you can see what's going on. Okay, 1 minus 0.20, that is going to give us 0.80. Okay, yeah, 0.20, because it can't be 80, because if we did 1 minus 80, then we would have ended up with 0.20. And we remember in the parentheses was 0.80. So if we do 1 minus 0.20, like the other ones are saying, that's going to give me 0.8. So like basically $1 minus 20 cents leaves me with 80 cents. That's the idea here. So 1 minus 2, 0 equals 0.80. It's a 1 minus 0.20 equals 0.80. All right. So the rate that it went down by 0.20. So just to recap real quick, they gave us the equation. We determined that it was decay because the number inside the parentheses was less than 1. All right, because decay is between 0 and 1. All right. Then we said they wanted us to figure out the decay factor or the decay rate. So we said, okay, 1 minus what gives us 0.80? And then y'all said, okay, well, 1 minus 0.20 gives us 0.80. So the rate of decay was 20%. All right, any questions there? Any questions about that? On YouTube and just in general, because it's a lot of people doing remote learning across the state and across the country. So if you're going all right, so last one, car for $25,000, but it depreciates at a rate of 10% a year. How much would the car be worth in 8 years? So the car is $25,000 right now, and it goes down in value by 10% per year. How much would the car be? Would that be a growth situation or a decay situation if the car is depreciating in value of 10% a year? Mm-hmm. You have a car that's $25,000 and it's depreciating in value by 10% a year, and they want to know the cost of the car after 8 years. So I was just asking, is it going to be growth or decay? I got 1, 2, 3, 4 people saying it's decay. Okay, 5 people say it's decay. Decay. Okay. All right. So for those who have been responding, it is true, it's decay. So you have this car, it's decaying at 10%, 10% a year. Most cars decay pretty quickly in value. So because it told us the percentage rate, remember, we're going to plug into this one. If it just said it was decreasing by half a year, we wouldn't put the 1 in the problem. So it's started out at 25,000, it's going down 10% a year, and it wants to know after 8 years how much the car costs. So it's going to be y equals 25,000 parentheses 1 minus 0.10, because it said it was decay and it was 10%. So the 10 is 0.10 as a percent, as a decimal. So the car started at $25,000. 1 minus the rate was 10%, and the time was 8 years. So we just put that in the calculator and we'll find out the value of the car after the 8-year time frame. So we put that in 25,000, parentheses 1 minus 0.10. Our exponent on it is going to be 8. So we find out after 10 years that car went down to $10,761.68 in value. So after 8 years, this is now the value of that car, $10,761.68. Okay. So that is it for the lesson. Real quick, these won't be long. The most I'm going to try to do is 30 minutes to 35 minutes because I know you have other classes and work you have to do. You can always come back and look at the video later because I have the link to the video to be on the channel, and it'll also be on the schedule for remote learning. So just in case you forget for some reason how to get to the channel, it'll be there. My weekend, to answer the question earlier, my weekend was busy, but you know, it was good trying to get ready for all of this. Yeah, so basically the videos will be from 8:15 to 8:45. That'll be around the time that it'll be. 8:50 at the latest, because like I said, you have other things you have to do. It is not going to last the whole class period. So the videos won't be 90 minutes. They're going to be real short, real sweet. Hopefully okay, so yeah, so people are asking, okay, so let me address a few things. Attendance, all right? So this is helping us keep track of who is here. As far as attendance purposes, it will not count against you if for some reason you cannot get in. It won't count against you if you are not, quote, in attendance during the live lessons, because unless you ask me during Google Meet, I wouldn't really know who was and who was not here. So you don't have to worry about that side. Generally with the live, I think it's kind of better because you get the lesson right then and right there, and you can go ahead and ask questions, right? Anybody else got a pressing question or something that you're confused about or concerned about before I end the live video? Hey, James. Anybody got any questions? Okay, so if there are no questions, remember, I have the live video in the morning. It'll be from 8:15 to 8:45. All right, you can join into the chat then. If you're asleep still, that's okay. You can come back and watch it later. Secondly, you have your assignments on USA Test Prep. It tells you when it's due. All right, so it's when it's assigned and when it's due. Please make sure you get it done. You get 2 attempts. These first one is 2 attempts per assignment. You can come back and watch the video as you're doing it for reference point, because I know we're not physically there in class. 3, if you have any questions, please just send me a remind message and we can get on Google Meet, or we can get on another platform if it's something I need to see that's on your screen. At the end of each class period, for the last 30 minutes of each class period, I will be available for one-on-one through Google Meet or the other platform to help you with anything you're having a problem with. Okay? So any last and final comments or concerns or issues? Google Meet, just go into the document. I put it in the chat earlier. I'll put it back in there again so you can have the link. It has a link to everything that's going to be there. So I'm adding it back in. All right, so there's the link to it again. All right. Yes, the live is going to be saved. The live is going to be saved. You can just, once I end this stream, it is going to upload to the channel on the schedule of assignments. So you can always go back to it and link for the live. Any other questions or comments? Well, if not, I hope you all have a good rest of your day. And I will hopefully talk to you soon.